Hello everyone. In this video, I'm solving some problems related to change of basis matrix. See, when you have two bases of r square, here it is given two bases of r square. You have to find the change of basis matrix P from E to S and Q from S to E. When two bases are given, then you know that this corresponds to one coordinate system and this corresponds to another coordinate system. To communicate between these two coordinate systems, we use the matrix change of basis matrix. So first case, from E to S means every vector of S is written as a linear combination of vectors of E. So 1, 3 equal to 1, 0 plus y times 0, 1. So it is easy because it is from standard basis to a new basis. So directly you can write x equal to 1, y equal to 3. Similarly, 1, 4 is written as x into 1, 0 plus y into 0, 1. This implies x equal to 1, y equal to 4. Now you have to write these coordinates. Coordinates of 1, 3 with respect to this basis is 1, 3 itself. You have to write that column wise 1, 3 and 1, 4. This gives you the matrix of change of basis from E to S. Okay. So, and this matrix P gives you the coordinates of any vector V in S to coordinates of any vector V in E. See, for example, if you have a vector like 1, 3 in S, what it is called in E, that is obtained using this 1, 1, 3, 4 into 1, 3. So this is equal to 1 plus 3, 4, 3 plus 12, that is 15. So 1, 3 in S is called as 4, 15 in E. This is standard coordinate system. This is a new coordinate system. So any vector of new coordinate system, if you want what it is in the old coordinate system, then you have to multiply that vector of a new coordinate system by the matrix P on the left. Similarly, if you have 1, 0 in S, then see here 3, 1, 1, 3, 4. 1, 0 is called as 1, then 3 in the old system. So which you already know, 1, 3. That is one of the element of the basis. So 1, 3 is called as 1, 0 in the new coordinate system. In the old coordinate system, it is called as 1, 3. So you have to remember, though it is a matrix of change of basis from E to S, it gives you the coordinate vectors of a vector in S to a vector in E. Next, similarly, second one, if you want to find out Q, which is a matrix of a change of basis from S to E, then every vector of E is written as a linear combination of vectors in S. That is 1, 0 is written as a linear combination of 1, 3 plus y into another vector is 1, 4. 1, 4. So similarly, in 0, 1 you have to write. This gives x plus y equal to 1 and 3x plus 4y equal to 0. Okay. Then 3x plus 3y equal to 3. Solve this. 3x plus 4y equal to 0. So this cancels. You will get minus y equal to 3, y equal to minus 3. Similarly, x equal to 1 plus 3, that is 4. X equal to 4, y equal to minus 3. Therefore, coordinates of 1, 0 are given by 4, minus 3. That is one column of Q is done. Then similarly, you have to get 0, 1 as a linear combination of y into 1, 4. Then x plus y equal to 0 and 3x plus 4y equal to 1. So this gives you 3x plus 3y equal to 0, 3x plus 4y equal to 1. Subtract minus y equal to minus 1, y equal to 1. When y equal to 1, x equal to minus 1. So you got the coordinates. Therefore, Q equal to, write them as columns. So 4, minus 3 and minus 1, 1. So this is the matrix of change of basis from the new coordinate system to old coordinate system. So it gives you the coordinate vector of any vector in the old system to new system. See, 4 minus 3 minus 1 1, the coordinate of 1 and 3. This is in old system. Our system, we call it as 1 and 3. What it is called in the new coordinate system? This 4 minus 3 1 minus 3 plus 3 0. So this is called as 1 0 in the new system. Okay. So this way we can get the matrix of change of basis. Change of basis from E to S gives you the coordinate vectors of any vector from S to E, reverse. So this is how we get the matrix of change of basis. From standard basis to any basis, it is easy. Just write these new basis vectors as the columns of that matrix. From S to E, new basis to old basis, you have to write every vector of old basis as a linear combination of new basis vectors. See here, one more question you can add to the same problem. Find coordinate vector v of this vector v equal to 5 comma minus 3 relative to s. So this is in our old system, and we have to find the coordinates of this vector which is in the old system to the new system. So how to get any coordinate of any vector from old system to new system? We have to multiply that vector v by the matrix q. Okay, q is from, see, it is like E to S means not using P here, you have to use P inverse, that is nothing but Q. 4 minus 1 minus 3 1 into V, that is 4 minus 1 minus 3 1 into V is 5 minus 3. This gives you 20 plus 3, 23 minus 15 minus 3 minus 18. These are the coordinates of the same vector 5 comma minus 3 in the new coordinate system. So remember, from E to S, the matrix of change of basis is P, but to get the coordinates from E to S, you have to multiply the vector by P inverse, which is nothing but Q. You can see that Q is nothing but inverse of P. Okay, what is your P? P equal to 1314. You know that what is how to get the inverse? Change these diagonal elements and change the sign of the remaining elements and divide it by the determinant. Determinant is 1. So which is nothing but 4 minus 3 minus 1 1, which is a Q. So Q is always inverse of P. See the next question. See, consider following bases of R square. Two bases are given. Now no standard basis, two bases are different bases. You have the first question here. Find the coordinates of v equal to a comma b relative to basis. Yes, first we have to get the coordinate vector of this vector. This vector is in our standard coordinate system. Now there are two new coordinate system. One is s and another is s dash. Now we have to find coordinates of this vector relative to the basis. Yes, means this vector is written as a linear combination of 1 minus 2 and 3 minus 4. So solve this system. X plus 3y equal to a and minus 2x minus 4y equal to b. So multiply by 2 here. 2x plus 6y equal to 2a minus 2x minus 4y equal to b. Now simplify this. 2y equal to 2a plus b, y equal to a plus b by 2. Now x equal to a minus 3y, which is a minus 3 into a plus b by 2. That gives you a minus 3a minus 3b by 2, which is equal to minus 2a minus 3b by 2. So now therefore you got the coordinates of a, b in the new system. A minus 2a, this is minus 2a minus 3b by 2 and a plus b by 2. These are the coordinates. The same vector a is called as this in the new coordinate system. Yes. Next question, second question is, you have to find the change of basis matrix. Find change of basis matrix P from S to S dash. So now it is not a standard basis. They both are different bases. Therefore, from S to S dash means what? Every vector of from S to S dash means every vector of S dash is written as a linear combination of vectors in S. So which we already found here, coordinate vector of any vector a comma b with respect to s is this. Therefore I have to find out where 1 comma 3 coordinate vectors of 1 3 and 3 8. So how to get that 1 3 coordinate vectors are, use this formula. So it is minus 2 minus 9 by 2, and here 1 plus 3 by 2. So that gives you minus 13 by 2, and this is 5 by 2. This is the coordinate vector of 1 3 with respect to the basis yes. Similarly, where this 3 8 goes to, apply the same thing. Minus 6 minus 24 by 2, and here 3 plus 8 by 2. So this is equal to minus 6 minus 12, and here 3 plus 4. Minus 18 and 7. Write them column wise. Therefore, matrix of change of basis P from S to S dash is minus 13 by 2, 5 by 2, minus 18 and 7. So, from S to S dash means every vector of S dash is written as linear combination of vectors in S. Next question is C. You have to find coordinate vectors of v equal to a comma b relative to basis s dash. Okay, coordinate vector of any vector a comma b relative to basis s dash means every vector a comma b is written as a linear combination of vectors in s dash. What are vectors in s dash? 1 3 and 3 comma 8. Solve this system. So it is x plus 3y equal to a, 3x plus 8y equal to b. So multiply by 3, 9y equal to 3a, 3x plus 8y equal to b. So minus y equal to 3a minus b. So x equal to a minus 3 into 3a minus b. So this a minus 9a plus 3b, which is 3b minus 8a. Therefore, coordinates of any vector a b with respect to basis s dash is given by 3b minus 8a and 3a minus b. So now we have to find out, next question is find matrix of change of basis. Matrix of change of basis. Find the matrix of change of basis from s dash to s. From s dash to s means every vector of s is written as a linear combination of s dash. That is nothing but getting coordinate vectors of s with respect to coordinate vectors of s dash, that we already have here. Therefore, find now. S vectors are 1 minus 2. What are the coordinate vectors? That is minus 6 minus 8, and here 3a. 3 plus 2. That gives you minus 14 and 5. Similarly, coordinate vectors of another vector of s, 3 minus 4, where it goes to minus 12 minus 24, then 9 plus 4. This goes to minus 36 and 13. Hence, you have to write the matrix of change of basis. Minus 14, 5, minus 36 and 13. Next, last case is you have to verify is Q equal to P inverse. So, what we got P as? P equal to 13 by 2, 5 by 2. So, minus 13 by 2, 5 by 2, minus 18 and 7. How to get the P inverse? Adjoint of P divided by determinant of P, that is P inverse. What is determinant of P? This is equal to, the determinant of P is minus 1 by 2 and adjoint of P is equal to 7 minus 13 by 2, then 18 minus 5 by 2. Now divide this adjoint by minus 1 by 2. So P inverse is adjoint of P divided by determinant of P, which is equal to 7 by minus 1 by 2, which is minus 14. 18 by minus 1 by 2, which gives you minus 36. Then 5 by 2 minus 1 by 2, which is 5. Then last one, it is 13. So Q equal to P inverse. This is how we find the matrix of change of basis.